Hello, this is Preetam Biswas. I have done the second task for the GRIP internship by the Sparks Foundation. It is a prediction using unsupervised machine learning, and the problem statement here is given as to predict the optimum number of clusters and represent it visually from the iris dataset. At first, I am importing the required libraries, which are namely pandas, numpy, matplotlib, sklearn. Then I am importing the dataset from the source. This is how the data looks. This is the shape of our data, that is 150 observations and 6 variables. Then I have checked for any null value in the data set, which is none in this case. Then I've shown some properties of the data, which is 150 entries and 6 columns with 6 variables, namely sepal length, sepal width, petal length, petal width, and these are the data types. Then I've shown the statistical properties of the data, which are count, mean, standard deviation, minimum value, maximum value, and the percentiles. Now, for the preparation of the data, I have dropped the columns species and ID because these are not required for the clustering, because species is a qualitative data type. Therefore, 4 columns are present in the data. Now, since clustering is sensitive to outliers, so they need to be removed. Hence, we check for outliers using box plot, and we can see that only sepal width has some outliers, so they are needed to be removed. Hence, we do that by using the interquartile method, range method, and plot the box plot again. And now we can see that the outliers has been removed successfully. Next, we go on to the k-means clustering method, and we do this by using elbow plot. Firstly, we do some arrangements to the data. Then we initialize the k-means and create several combinations and observe the within cluster sum of squares. Then we print the values. So our values are look like this. Next, we go on to plotting the values as the elbow plot, which means comes out like this. Now we see there is a formation of elbow. Till the third point we get an elbow, so we can predict from here that the optimum value for the number of clusters should be 3. If there is some ambiguity, then we move on to make it sure by using a silhouette plot. Firstly, we initialize the k-means, then we import the silhouette visualizer to plot the silhouette plots. I've plotted here it for 2, 3, 4, and 5 clusters, and it comes out like this. So here it shows that for 4 and 5 clusters, most of the points are below the average silhouette line, so they are not very good choices. Besides, the thickness of the clusters are quite varying. Basically, they are not same. So 4 and 5 clusters were not suitable choices. Now for deciding within 2 and 3 clusters, we see that in 2 clusters, the thickness of the below cluster is quite more than the above one. So here also the thickness are not same. While in the 3 clusters case, the thicknesses are quite uniform, and also there are values for all the clusters above the average silhouette line. So from here it is also clear that the best value for the number of clusters should be 3. Also, we plot the silhouette scores in a graph, and we can observe that the value for 3 has come out to be the maximum, which is the optimum value. So from here, combining our two plots, the sellout method shows the optimum value of k is to be 3. Next, we visualize the clusters using the k-means classifier, and we plot the clusters for the first two columns here, which are namely sepal length and sepal width, along with their centroids, and it's come out to be like this, the three clusters with their centroids. Lastly, we visualize the clusters for the third and the fourth column, which are namely petal length and petal width, along with their centroids, which is in this form. So there are the visual representations of the clusters. Hence, we have predicted the optimal number of clusters, which has come out to be 3, and represented it visually. Thank you.